Hello everyone. Today we will discuss different types of operating system. So first operating system which I am going to discuss here is batch operating system. So what do you mean by batch operating system? So if I talk about batch operating system, it is nothing but your sections in your class. That means based on some criteria, we divide our students in some sections. Okay, fourth semester section A, fourth semester section B, like that. In this case also, based on some similarity, we have divided our jobs into batches. Here you can see there are two batches, batch 1 and batch 2. Let's say batch 1 is similar kind. Let's say it is in the written in the C program, and batch 2 it is written in the COBOL, Fortran, etc, etc. So based on some similarity we have divided, not actually we have divided, the operator is divided these batches. Okay, now coming to this point, if n number of users are there, if n number of users are there and they are interested to execute their jobs in the batch operating system or in the CPU, then what will happen in this operating system? So we will discuss here now. So job means, before discussing batch operating system, what do you mean by job? Job, it is in simple terms, if I say job is nothing but your program, but in batch operating system, jobs also carry more than program. That means in a job, program plus input output data and then control informations are also available. But for this simplicity, I just consider job means it is nothing but your program. So if n number of users are there, okay, and then they are interested to submit their jobs in this CPU with the help of batch operating system, then there is a operator who will going to handle all those jobs. If user 1 submitted their job 1 in this in the operator, then similarly n number of users are submitting their jobs, and based on some criteria, I'm again repeating, based on some similarity of jobs, the operator is divided batch 1, batch 2, like that. Now after that, this batch 1 is submitted to CPU. Okay, this batch 1 will first submit to this CPU. Then after that it is completed, then only we can submit the batch 2. Batch 1 is completed its execution in the CPU, then we can submit batch 2. All those uh, uh, all those things are controlled by this operator. That means user is not handling all those things, and that is why it is not interactive. Okay, it is not interactive because user is not interacting with this system. There is an operator who is going to handle all those input output and everything. That is why this disadvantage of this type of operating system is non-interactive. First is non-interactive. Okay, so what is non-preemptive? What is non-preemptive? Non-preemptive means, first of all, we will discuss preemptive. What do you mean by preemptive? Preemptive means we can forcefully drag out some processes or jobs from the CPU. So non-preemptive means it is just the opposite of preemptive. We cannot forcefully pull out any job from the CPU in case of batch operating system. It means if job 1 is submitted first in this CPU with the help of batch operating system, until and unless it is not finishes its execution, we cannot drag out or pull out this job 1 forcefully from the CPU. Okay, that is why it is called non-preemptive. Preemptive means we can drag out forcefully from the CPU. Non-preemptive means we cannot pull out any job from the CPU until and unless it is finishes its execution. So it is a non-preemptive execution execution mode of operating system. And then we have discussed why it is non-interactive, because in this batch operating system user is doing nothing. User is just simply handed over each job to this operator, and operator is taken care of from this point, and he is responsible for input, output, and then execution. That means user is not doing anything, only the operator is taking care of all those things. Then second disadvantage of this type of operating system is starvation. So what is starvation? Starvation means, if let's say this is your job 1, okay, and this is the biggest job in this batch 1 and batch 2. Let's say it will take 1 hour to execute to complete its execution. But job number 4, job number 2, job number 5, and job number 7, these jobs needs only 1 or 2 minutes. But due to this heavy job number 1, which will need 1 hour execution, okay, these all the other jobs needs to wait for their turn, because we cannot forcefully pull out any job from this batch operating system. That is why it is called non-preemptive. And due to this, all the other jobs are waiting in the queue due to this heavy job number 1, and it creates, or it may create starvation. Starvation means it is a long time of waiting for long time. So these jobs need only 2-3 seconds or 2-3 minutes, but due to this heavy job, or job number 1 is will take 1 hour execution, all the other remaining jobs will wait in the queue for long time, and that scenario is called starvation. Okay, then in the third disadvantage of this type of batch operating system is CPU is ideal most of the time if any one of these jobs are involved in input output handling. Let's say this job number 4 needs some input output, so it is it is removed from the CPU to finish that input output, but we cannot submit any other job from this batch 2 until and unless this batch is not complete. Again, because of this, due to this non-preemptive nature of this operating system, we cannot forcefully pull out from this batch 1 from the CPU. And that is why, even if CPU is ideal, CPU is not doing anything, because job number 1 is, let's say, completed, and job number 4 is handling its input output. But CPU is ideal, okay, we can submit job 2 here, job 5 here, job 7 here also, but we are not doing that because of the non-preemptive nature of this batch operating system. And that is why the CPU is ideal most of the time if input output is involved in batch operating system. So the next operating system is multi-programming operating system. So what do you mean by multi-programming operating system? As I told in the previous slide, that batch operating system, we are submitting our jobs in batch, but in the multi-programming operating system, that is not like that. We can submit our jobs at any fashion. Okay, let's say there are 3 jobs in the main memory: job A, job B, and job C. Now job A is involved writing some output data. That means this is my secondary disk storage space, and job A currently writing some output data. It means it is the first job which needs to be executed, but due to this input output execution, it is not going to execute first. Then in case of batch operating system, we need to wait here. We can't execute the other remaining jobs, but multi-programming operating system suggests that you can execute the second one, job B, okay, if this job B is doing some input output, you can submit job B in the CPU to execute in the CPU. Okay, it is in the case of multi-programming operating system, but it is not true for your batch operating system. Until and unless job A is not completed its execution, you cannot submit job B in case of batch operating system. Okay, but in case of multi-programming operating system, you can submit job B if job A is involved in input output handling. So this is the main difference between your batch operating system and multi-programming operating system. And due to this behavior, multi-programming is more efficient than batch operating system because the waiting time is less in case of multi-programming operating system. Now, third kind of operating system is multitasking, or you can say time sharing operating system. It is just an extension of multi-programming operating system. So multitasking is extension of multi-programming. Everything is same, only difference is in case of multitasking or time sharing operating system, it is non-preemptive. It is a non-preemptive operating system, and due to this non-preemptive nature, we can forcefully drag out processes or jobs from the main memory, from the CPU. And it is a time sharing operating system. Let's say, in this operating system, job A will execute for 2 seconds, job B will execute for again 2 seconds, job C will execute for again 2 seconds. Like that, they have shared their execution time in the CPU, and that is why this is called time sharing operating system. All the jobs are shared the execution time in the times in the multitasking operating system. And the best example of this multitasking operating system is round robin algorithm. That means in the round robin algorithm, they 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 execute their processes in a time quantum manner. That means in the time allotted they have, that means the processes are allotted for 2 seconds, let's say. After that, P1 process or job A will be pulled out and job B will be given charge. Again, after 2 seconds, job B execution, that means it will be pulled back. Okay, forcefully it will be dragged out from the CPU, then job C will inserted there. So like that, all the jobs will going for execution one by one for their time allotted. Okay, then in the multi-processing operating system, it is having more than one CPU. All the remaining operating systems, your batch operating system, multi-programming operating system, multitasking operating system, they have only single CPU. But in case of multi-processing operating system, more than one CPU is available, and that is why you can simultaneously execute more than one job or process or program. Then in the last one is real-time operating system, RTOS. In the real-time operating system, these are actually time-bound operating system. Let's say if you have a time bomb, at that time your bomb needs to be executed or bomb needs to be blast at the accurate time. So in this type, that type of instrument or bomb needs this type of real-time operating system. Let's say one missile. So in that missile also you need real-time operating system because they are time bound. Okay, thank you.